as we continue our discussion of three-dimensional figures, we're now going to look at how to find the volumes of those figures with prisms and cylinders. We looked at surface area before, and again, surface area for each of these figures, you find the lateral area, add to it the area of 2 times the base of the figure. Now we're going to look at how to find the volume of each of these, so the amount of stuff that it holds. The volume of a solid is the number of cubic units that are contained in its interior, and so it's measured in cubic units. And the reason it's measured in cubic units is because we're actually going to multiply in 3 dimensions. 1 dimension, 2 dimensions, 3 dimensions. So whereas before we had just 2 dimensions for area, now we're adding that third, so we have cubic units. Very important to consider. So the volume of a prism, very straightforward. You may have seen it slightly differently before, but the volume is the area of the base times the height. Some of you may have seen, particularly for a rectangular prism, length times width times height. Well, keep in mind that length times width, that's finding the area of the base. So we do the area of the base times the height. So in this example, what is the volume of the rectangular prism? Well, volume is the area of the base times the height. The area of the base in this one is going to be 24 times 20 times the height, which is 10. Put this into our calculator, we get 4,800. Our unit is centimeters, so our answer is cubic centimeters, or centimeters cubed. For this example, volume again is the area of the base times the height. So the area of the base, we would do 5 times 3 times a height of 4. Now, to make it really easy, we can do this in our heads. 5 times 4 is 20, times 3 is 60. Our unit is feet, so our answer is in cubic feet. Here we have a triangular prism. Again, volume is the area of the base times the height. Now the base in this case is the triangle, and so to find the area of that, we do 1/2 times the base of the triangle, which is 6, times the height of the triangle, which is 10, times the height of the prism, which is 5. Now notice, the height of this prism isn't going up and down like we typically think of height, but remember, height of a prism is the distance between the 2 bases. So since the base here is the front and the back, then the height of it is that side between the 2. Okay, so 1/2 times 6 is 3, times 10 is 30, times 5, we get 150. Our unit was meters, so we have cubic meters, or meters cubed. Now to find the volume of a cylinder, it's the same idea. We're doing the area of the base. The base is a circle, so we have pi r squared, times the height. So let's look at an example. Volume for a cylinder is pi r squared h, the area of the base, times the height. Now we're going to leave this answer in terms of pi. So we have pi times our radius, which is 3, quantity squared, times the height, which is 8. Okay, 3 squared is 9. 9 times 8 is 72, so we have 72 pi. Our unit was centimeters, so our answer is cubic centimeters. So 72 cubic centimeters. For our next example, now we have an oblique cylinder, but we have our height of 3 meters. So again, volume is pi r squared, that's the area of the base, times the height. So pi times the radius. Now, it tells us that this is 2 meters, that's the diameter. Radius is half of that, so we have 1 quantity squared times a height of 3. 1 squared is 1, times 3 is 3. So we have 3 pi, our unit was meters, so our answer is in cubic meters. So we have a volume of 3 pi cubic meters. Sometimes we will get figures that are slightly more complicated, composite figures. This is a 3-dimensional figure that's a combination of 2 or more simpler figures. So in this example, if we want to find the volume of this aquarium, we can break it up. I draw this in and think about it as this figure here, which is a prism, and then the curved part would be half of, or since this is a semicircle, would be half of a cylinder. Okay, so we would have the volume of the prism plus the volume of that part of the cylinder. So let's start with the prism. All right, so volume of the prism. It's going to be the area of the base times the height. Now the base in this one, it tells us this whole thing is 48. Well, let's think about that. That includes this distance right here, which would be a radius of this. Now, this is a radius, and that's also a radius. So if the diameter is 24 inches, then the radius would be 12 inches. Okay? Well, that means that this part right here is going to be 48 minus that 12, or 36. Okay, so the area of my base is going to be 36 times 24, right, for what would be the length and the width, times the height, which is 24. Okay, so we have 36 times 24 times 24, we get 20,736. Now, if we think of the other part, so the volume of our half cylinder is going to be half a cylinder, so it is 1/2 times the area of the base, which is pi r squared, times the height. So we have 1/2 times pi. Now we already discovered our radius is 12, so we have 12 quantity squared times a height of 24. Okay, so we do 1/2 times 12 times 12 times 24, we get 1,728 pi. The volume of the whole thing is those two added together, so 20,736 plus 1,728 pi. If I round that to the nearest hundredth, I get 26,164 and 67 hundredths. My units were inches, so I have cubic inches. Okay. Very straightforward, very easy. The hardest part is going to be figuring out, okay, how to divide up the figure, and then if I need to identify other links. But just think about what you've got, break up the figure into the smallest pieces that you need to.